So this is section 2.1, and I just wanted to show you a little bit from the textbook, the ebook that you have in WebAssign, and then we'll do a couple problems to get you ready for your assignment. So what we're talking about in section 2.1 is the derivative. It's the beginning of the derivative, and the derivative measures the slope of the tangent line to any graph. So for example, if we look at this parabola, at any particular point in the parabola, the tangent line gives an estimate of the slope of the graph, or the slope of the curve. So at the very top, at the vertex, the tangent line is a line that would be drawn to just touch this curve in one spot. And so they drew a tangent line there at the vertex of the parabola, and the slope of that tangent line, since it's a horizontal line, is 0. Over here, where the parabola is on the rise, the tangent lines to that curve, they're a little hard to see, but it's a line right here with a positive slope. And here, the same thing, the tangent line would be a line right here with a positive slope that just barely touches the graph. And as you go past the vertex to this point over here, the tangent line that would be drawn there would have a negative slope. And again, the tangent line is giving you an estimate of what the curve is doing at a particular point. If we look down at the graphs here, there's a couple other examples. Again, the tangent line at the vertex of a parabola is horizontal, has a 0 slope, and that's going to be important to us later on. For this curve, the tangent at P has a positive slope, and for this curve, the tangent at P has a negative slope. And that's what we're going to be trying to find, the slope of the tangent line, or sometimes the equation of the tangent line. The idea of a tangent with the circle that you see here, when you study geometry, you probably studied the idea of a tangent to a circle, and this is a lot like it. So I'm just trying to go to the next page. On the next page in your textbook, you can see that if they give you a graph and they draw the tangent line for you, one of your homework problems, they're going to ask you to estimate the slope of that line. So in this case, you can see, hopefully you remember that slope is measures the change in y over the change in x. So in this case, the change in y, or the rise, is 2. The change in x, or the run, is 1. And so the slope of this line would be 2. So you're going to have to do that in one of your homework problems. You also are going to, that was my husband sneezing. Bless you. We're going to, on the next page, you're going to have to understand how you would go about finding that tangent line yourself, or the slope of the tangent line yourself. And it has to do with the difference quotient, which is going to be on the test that you're going to take the next time I see you. And so this is the difference quotient right here. You should recognize it. That measures the slope of a secant line. And that's what we're going to move to now on another piece of paper, talking about how this slope of the secant line helps you figure out the slope of a tangent line. So we're moving to this worksheet. And this graph right here, this curve, would be our function. And if we were trying to find the slope of the tangent line right here at this point on the curve, we could imagine a line being drawn that's tangent there. The way we find that tangent line is we start with a secant line. And a secant line is a line that connects 2 points on the curve, where a tangent line is a line that touches the curve in 1 point. The secant line has 2 points, and it's connecting them. So the slope of the secant is the change in y, which is this f of x plus delta x minus f of x, over the change in x, which is what we're going to call delta x. So delta x is the difference in the x values when you go from one point to the other point. That's the denominator of your slope. This is the change in x. The way that you see the change in y is, remember that if I call this x value x, and this is delta x, the x value at this point would be x plus delta x. It's whatever this number is plus whatever the change in x is. So if this were 10 and this was 3, this would be 13. If this was 1 and this was 6, this would be 7. This is my beginning x value. This is how much my x value is going to change. This is my ending x value. The y value, that you always measure your y value by taking it over to the y-axis and measuring the function value at that x value. So the y value of this point is f of x, and the y value of this point is f of x plus delta x, the function value for this x value. And when you take f of x plus delta x minus f of x, that measures this change, which is your change in y, the change in the y value. So in order to get the slope of a secant, the difference quotient will give that to us. Then to figure out the tangent, what the process is you move the point that you used for your secant a little bit closer, and you figure out the slope of that secant. Then you move the point a little bit closer, and you figure out the slope of that secant. And you keep doing that, moving this point in closer and closer until this point ends up right on top of your original point. And what you're doing as you move those points closer and closer, every time you move it closer, you can figure out a different slope. When this point ends up on top of that point, you really can't figure out a slope because you don't have 2 points, and that's what you need. But that's why we learned how to take the limit. So if you put together the idea of limit and the idea of difference quotient, you will get derivative. The slope, or little m, we're calling that the slope of the tangent line, and that is the derivative, is the limit as this delta x, this change in x, goes to 0, gets smaller and smaller and smaller. And so you take the slope of the secant, which is this, and you take the limit as delta x gets smaller and smaller and smaller, goes to 0, and that is how you find the slope of your tangent line. So if you look back at the book, the ebook, they show a good picture of that, what I just tried to show you. They're moving the point that they're using for secant closer, closer, till it's the same point. And doing that limit is giving them the slope of the tangent line, which is, by definition, the derivative. So if we look at the next page, when they say to find the slope by the limit process or find the slope by the derivative, that's the definition they want you to use. So I'm going to do an example of what that would look like. If you had a function like x squared plus 2, and I wanted to find the derivative or find the slope of the tangent line for that function, what I want to do is do the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, the difference quotient. But if you remember in class, I said that I prefer to call this delta x h, because when you have an x and you have a delta x in the problem, sometimes it gets confusing. So my way of dealing with that, and a lot of people in calculus decide to call that delta x h, and so we're going to do that. That shouldn't be new to you. What you have to be able to do, and this is good for review for your test, is write the difference quotient for this particular function. And what that means is, instead of x, it's x plus h squared plus 2. This is f of x plus h minus, and then you put your original function in, x squared plus 2 all over h, just like on your review sheet. So we're going to forget about the limit for a minute and just simplify our difference quotient like we've done before. And this is going to simplify to x squared plus 2xh plus h squared when we FOIL this, plus 2, and then we're going to distribute our negative, minus x squared minus 2 all over h. We haven't taken the limit yet, so I got to keep writing that. But my x squared and my negative x squared go to 0. My 2 and my negative 2 go to 0. I'm going to divide my h out. So I'm going to have to factor an h out of the numerator so that I can divide it away. And I'm going to be taking the limit as h goes to 0 on 2x plus h. So the way you take a limit is you try to send the variable to what you're trying to approach and see if you have any problems with it, and in this case I won't, because my answer will just be 2x. So what 2x is my derivative. It is the slope of the tangent line for any particular point. So if I asked for the slope of the tangent to this curve at the point 1, 3, which is a point on the curve, what I would do is I'd take the x value of the point that I'm talking about and I would plug it into my tangent. This is the rule for slope. 2x is the rule for the slope of the tangent. So at 1, 3, that slope is 2 times 1, or 2. If I wanted to know the slope of the tangent at a different point, negative 2, 6, that's a point on my curve. The slope there would be 2 times the x value of negative 2. The slope at that point is negative 4. So this is going to be a very powerful rule that we're going to use all the way through chapter 2. If you put together what you know about limits and what you know about a difference quotient, you should be able to do any of the homework in this section. Again, this is section 2.1, day 1.